That's very interesting. What, now Duhem passed away in what, 1916?
1916, yes.
So this is the 80th anniversary of his demise.
Yes.
And to think that he's still a thinker who is not known by the general public, but is known by the intelligentsia of the field of history and philosophy of science,
Right.
is really quite interesting to think of the impact of such a man.
Right. There are actually some equations. I think the Duhem-Margulis equations in chemistry. I think I don't want to get too far off my field, which is history and philosophy of science. But he was a first-rate physicist, chemist, and as I can see, you also have a book of his landscapes, so that he did caricature and landscapes. I'm not sure whether one can call him a first-rate artist, but clearly polymath is the word that you would use. The work in history of science and philosophy of science, I think, has enormous and long-lasting value. I don't believe that one can be taught a class in the philosophy of science without encountering what is commonly called the Duhem-Quine thesis about the non-falsification of scientific hypotheses. Willard Quine, a Harvard professor of philosophy, possibly one of the best-known American philosophers, rediscovered something Quine said, though possibly independently. In his major work called Two Dogmas of Empiricism, he refers in a footnote to similar thoughts by Duhem that science doesn't get falsified, individual hypotheses don't get falsified, but perhaps science as a whole might. So that this is a counter to the kind of thought that science has a method which is almost automatic of falsification of single hypotheses and as it were, adding up of unfalsified hypotheses which are then corroborated. Duhem denied that single hypotheses could be decisively falsified because he felt that physics, at least, had achieved the stage in which when a hypothesis does not confront experience by itself, it confronts experience with a buffer of other theories, with theories about measurements, instruments that require theories, auxiliary hypotheses, and so that it's the whole of physics that comes into play in a particular experiment, not a specific hypothesis. So when something goes wrong, the scientist then can't be knows something's gone wrong, but can't be confident about what it is specifically that has gone wrong. It isn't necessarily a hypothesis that has been falsified. The Duhem-Quine thesis is actually an important thesis in the philosophy of science. I see you also have one of our students at Virginia Tech, Zhang Laizhu, who has translated Duhem's main philosophical work, The Aim and Structure of Physical Theory, in Chinese. He was kind enough to give me a copy of it. I can attest that this is the aim and structure of physical theory, but that's all I can do. So Duhem reaches far and wide. This is a modern Chinese. It's just a few years old, a modern Chinese translation of Duhem.
You've written another book too here, is that right?
Oh, well, thank you. This is a collection of essays on the issue of whether one should think of science, the relationship between science in the 17th century and science earlier, late medieval and early modern science, whether one should better think of it as 17th century science as a break from earlier science or as continuous from early science. So what is investigated in this book, I'm only the editor, one of the editors. I have an article in there about 17th century geology, But the various contributors all have considered this issue of whether, in fact, Duhem was right in thinking of science as continuous, or whether it's better to think of science as discontinuous, as going from leaps and bounds and spurting into revolutions, breaking from the past, which is, of course, the image that one has of the scientific revolution of Galileo, of Descartes, of Copernicus. Duhem's main work is in fact to show that the Galileos, the Descartes, and the Copernicuses knew very well the results of the 14th century scientists and built upon them. They, of course, they progressed, they changed, they were not static. One doesn't have to think of science as frozen in time to think that, in fact, there is continuity.